Okay, so welcome again to the UK's Greenhouse Gas Removal Research Programme webinar series. Like I said, this is the final webinar in our series, and I'm delighted to welcome our speaker for today, which is Professor Duncan McLaren, who's Professor in Practice and Research Fellow at Lancaster University. Duncan's works broadly across issues to do with justice and the political implications of novel technologies. And you'll see that he's worked in the past on things like climate change, circular economy, and smart cities. So we're delighted to hear from him today. He's presenting on behalf of the research project Assessing Mitigation Deterrence and Effects of GGRs. Mitigation deterrence is I suppose, the artist formerly known as moral hazard, which I'm sure Duncan will introduce and tell us all about as part of his talk. So without further ado, Duncan, I'll stop sharing my screen and you can start sharing yours. So thanks a lot.
Thanks very much for that introduction, Phil. Try that again, share screen. Up we go, hopefully. And slide view. All right, that I hope is visible to everyone.
That's great, thanks.
Great, so thanks for that introduction. At this moment, really just a nod to the other team members listed here who were from Lancaster Environment Centre and the Sociology Department. And Nils Markussen, the PI, is fortunately with us in the Zoom room, so any difficult questions, I'll just pass them on to him. And a nod also here to the funders, as the same as the whole GGR programme. I'm not going to spend the time talking through them. So what I'm going to do today, given this audience is quite knowledgeable about GGR, I'll skip quite quickly through the introduction to GGR, spend a little time on mitigation deterrence, starting with its history and possible scale and drivers. And then towards the end, I'm going to present some of the work that we've yet to finalise and publish before concluding with some suggestions for policy and research implications. The scales here in the corner are a reminder that uncertain promises of future removals are not directly equivalent to emissions cuts today, and that the timing of reductions, of course, matters also for the overall climate impact. So we have to acknowledge that in practice, a tonne of CO2 is not just a tonne of CO2. Not all units of CO2 are equal. Again, stuff that all of you, I'm sure, really know, but just to note that GGR is in many respects a construction of climate budgeting. It's made possible by thinking about the climate problem as a budget issue. And despite uncertainties in carbon budget calculations, what's left to safely stay within 1.5 degrees C is measured in years, or maybe, if we're really lucky, more than a decade, but it may also be already gone. In the calculations I'll show you later, we use a range of 80 to 176 gigatons of carbon remaining from 2020. That's based on the IPCC's special report on 1.5 degrees C, and contrasts with annual emissions that are running at around 10 gigatons of carbon a year. So introducing GGR, we've taken the definition of greenhouse gas removal as large-scale means to remove greenhouse gases from the atmosphere and sequester the carbon. For our purposes here, it's synonymous with carbon dioxide removal, carbon removal, negative emissions techniques. In our project, we considered 4 specific techniques illustrated here. So bioenergy with carbon capture and storage, illustrated by a plant that's capturing CO2 for fermentation, from fermentation of corn ethanol. Enhanced weathering, illustrated with a basalt quarry, a source of the basic rock dust that's spread on agricultural land in enhanced weathering experiments. Third picture is a soil profile under pasture, showing the rich organic material, thus potential carbon store in the soil. And finally, the well-known, I think now, artist's impression of a direct air capture array, the sort proposed by Carbon Engineering, but much larger than their current demonstration plant in British Columbia. We also, however, looked at GGR as a generic category, a sort of thing in itself. The central inspiration or insight guiding our work was that, unlike the Lego bricks shown here, climate policies and technologies are not simply additive. You can't just pile them on top of one another. They interact, and they interact as promises and expectations, as well as interacting as material deployments. And all of that interaction happens on an already distorted playing field. So our work aimed to identify, understand, and estimate the scale of possible perverse effects, not so as to resist the development of GGR techniques, but so as to maximize the chance that they can be deployed effectively as a supplement to accelerated mitigation. In other words, we were exploring how we could get both rather than neither. The Lego bricks also serve another purpose here. They serve as a reminder of the, shall we say, somewhat simplified, perhaps even childlike nature of much modelling work in this space. That might sound a little harsh, but one example of such simplistic modelling would be the widely castigated but dangerously influential case of tree restoration. An article published in Science that modelled 0.9 billion hectares, 3 trillion trees, $300 billion cost. That equates to 50 cents a tonne of carbon dioxide, which sounds wonderful. And not surprisingly, got widely adopted and retweeted by the people you might expect: Greta Thunberg, Christiana Figueres, George Monbiot, but also by US Republicans who perhaps had a rather different view of how useful it was to talk about cheap forest offsets. So I'm trying to be a bit provocative here deliberately. Mitigation deterrence can result from well-intentioned research, but also through deliberate exaggeration. The little picture of the Flybe aircraft, I mean, it's a little while since Flybe was bailed out, but it's there to remind us that governments and businesses do try to prolong emissions, sweat assets, avoid the hard decisions, even if all they can come up with as a defense for it is a transparent untruth, such as Matt Hancock's claim that aviation is already decarbonized. More typically, mitigation deterrence problems are deeply systematic, as the example of bioenergy with carbon capture and storage suggests. CCS was widely touted as a way to cut emissions from coal combustion. New plants were justified as capture ready, which in reality meant little more than having enough space to build an extension to the plant, otherwise known as a car park that you see in the picture. But the promise of fossil CCS allowed delay in replacing fossil energy with renewables. The promise of BECCS, largely created within the model world by combining bioenergy and CCS technologies, which seem to exist separately in the models, established the idea of negative emissions rather than just cuts in emissions, and thus allowed postponement and delay within model land on any mitigation. Interestingly, BECCS in the models was CCS bolted on to biomass combustion at large scale. Drax is testing this, although so far I understand it's failing even to reach its 1 tonne per day target. And in reality, BECCS is there's not much of it, but what there is largely about ethanol fermentation. It's an easy niche application, partial removal of carbon dioxide, and supplying carbon dioxide to enhanced oil recovery. So not actually doing greenhouse gas removal in the first place. But looking back into the models, because the costs of these future technologies in the models are discounted, models assuming continued economic growth, they appear very cheap in the future, and thus the models, which are cost optimizing machines, select them preferentially over what appears to be more expensive emissions reduction in the near term. The costs of side effects, such as competition for food producing land or water, were not so well modelled, and critique exposed these problems. But typically then the modellers shifted to calling BECCS a placeholder for other GGR promises, and the procrastination was still possible. So BECCS illustrates well how technologies and technological promises co-evolve with climate politics and modelling. In examining the histories of the 4 GGR technologies we were interested in, and indeed others, we started to see how this applied to other technologies in the evolution of climate policy. And there's a reference there in the corner for the piece we got published on this, that this problem was contributing to the ongoing delay in action sought by climate denialists. A critical step in this process incorporates the reframing of climate targets and the metrics used to express them. As you see in the left-hand column here, that framing changed several times over the past decades. And each shift in the framing of targets, while seeming perhaps a more precise interpretation of the Climate Convention goal of avoiding dangerous anthropogenic impacts on the climate, also permitted more flexibility in how the targets could be met, and thus more delay awaiting the delivery of novel technological promises. Again, to illustrate with BECCS, BECCS is only partly an emissions reduction technology, so its claimed benefits did not fit well in a target framing of 50% or 80% emissions cuts by a certain date. It fit rather better with a framing of achieving a particular outcome concentration or squaring a particular carbon budget. Rather worryingly, looking forward, solar geoengineering technologies don't fit those framings, but do fit framings of achieving a particular temperature outcome. So I've gone pretty deep into the weeds here and examples and history. I'm going to pause a little and clarify the definition of mitigation deterrence that we've been using, which is the prospect of reduced or delayed emissions reduction resulting from the introduction or consideration of another climate intervention. Note that here we're not just talking of GGR, but of interactions between different interventions. Nuclear promises could deter energy efficiency or renewables development. Promises about behavioural change could deter GGR development. GGR, however, is unusual and we think, or I think, potentially more pernicious in that it promises to work like a time machine, removing carbon dioxide from the atmosphere and reversing, not just slowing or halting, the process of climate change. The other thing to note here is, as Phil said, yes, the art is formerly known as moral hazard. We've deliberately moved away from that commonly used term in geoengineering literature, not just because this seems to be heard as an attack on the morals of people involved, but more importantly, because the processes we've documented here are more complicated. They're collective, they're emergent, they arise in conditions of deep uncertainty and ignorance. They're not the classic moral hazard problem of decisions by individuals made in the face of known risks and expectations. So how serious could this problem be? Is mitigation deterrence just a marginal thing that we might be best ignoring? To try and assess this, we developed a novel carbon at risk approach based on carbon budget modelling to try and quantify the risk. That means that the three types here are, in fact, partly defined the way they are because that allows us to quantify them. There's an interesting reflection there for us about how our method in turn reflected the technologies involved. But anyway, we came up with this model of saying, okay, first let's see how much GGR do the models anticipate, and ask what happens if it goes on being promised but never materializes, or for some reason fails. If the carbon captured is diverted to CCU, for example, to utilization, or if it's in biological stores that are weakened by wildfires or droughts. Secondly, if that much GGR is being done, been made material, what rebounds might arise from the land use change to supply biomass, for example, or from use in enhanced oil recovery of the captured GGR. And thirdly, what if people expect more than is actually practical to deliver and hold off on expensive or difficult mitigation? That's the most similar to the classic moral hazard assumption. And to try and get a handle on that, we looked at how much remaining emissions reduction would cost over about $100 per tonne of carbon dioxide, on the assumption that promises of GGR are quite often suggest that GGR will be cheaper than that threshold, and that it might seem quite rational to someone to hold off in the hope of using GGR instead. Those three types are additive, but note, however, that the quantity at risk in type 3 is inversely correlated to type 1, because when more substitution is planned, there are fewer remaining expensive mitigation expectations. So that's why the numbers in the type 3 run in the opposite direction to the numbers in type 1 and type 2. This gives a total carbon at risk in gigatons of carbon. And you see the numbers are fairly substantial. The worst case arises with exaggerated promises, generating large type 1 risks, significant type 3 risk, and then substantial efforts to implement, resulting in significant type 2 rebounds, if there is also failure to deliver long-term storage. The central estimate is not the worst case. The central estimate is almost 500 billion tonnes of carbon at risk and implies an additional 0.7 degrees centigrade warming at a median estimate of climate sensitivity, an outcome of 2.2 degrees C rather than 1.5 degrees C, all else being equal. The worst case, combined with high climate sensitivity, would mean an additional 1.4 degrees C, taking us close to 3 degrees C outcome. So these things are not small. Those are worst case scenarios, but there is a justification for looking at worst case scenarios and doing what we can to avoid them. So if we are, as that analysis suggests, constructing future pathways, at least in model land, with huge but potentially imaginary carbon removal, how should we understand that process? Is it an objective need that's eliciting new technology to meet that need in a highly rational way? Or is, to go to the other extreme, is it a cultural way of life fighting for its survival by inventing imaginary ways to solve the problem of climate change in the future? Or some combination somewhere in between those. Our theoretical framework to engage with this draws on cultural political economy, which adds several dimensions to the constructivist science and technology studies understanding of technology. It attempts to reintegrate materiality with particular respect for the recalcitrance of Earth systems. It recognizes the political economy of interest groups, and particularly of financial interests. It sees political regimes, such as the current neoliberal version of capitalism, as mobilizing spatio-technical fixes to sustain themselves, and understands regimes as co-evolved with social imaginaries, which encompass broad yet conditioning understandings of how the world and society work. And it sees new technologies as inextricably embedded in the co-evolution, not just of promises and applications, but also of the encompassing policy and political regimes. So to try and bring those two sets of thinking together and to attempt to explore how and where mitigation deterrence might arise, we used processes of stakeholder deliberation, and we developed and applied futures scenarios to help those work or for those stakeholder workshops. Our scenarios map out alternate political futures, 4 of them. First, in which things muddle on. Secondly, where neoliberalism is revived, partly in a new Chinese-led model, although it's not essential that it's Chinese-led, but that delivers strong markets. Thirdly, in which a populist trend accelerates into authoritarianism, delivering strong leaders. And finally, or alternatively, one in which that populist trend is reversed in a progressive backlash, delivering a more egalitarian politics with strong publics. So in one sense, all 3 alternatives to business as usual are someone's idea of utopia: strong leaders, strong markets, or strong publics. Each scenario also involved a number of variants to explore different technologies, and there we drew on interviews with technology experts to suggest the nature, scale, and risks regarding the particular GGR. To limit the number of variants to a manageable level, we paired the 4 political scenarios and allocated each technology to a specific pairing. So for BECCS and soil carbon storage, we developed business as usual and progressive scenarios. And for direct air capture and enhanced weathering, we created authoritarian and neoliberalism 2.0 scenarios. Workshops which engaged with mitigation deterrence across a generic GGR portfolio considered both pairs of political scenarios. In each workshop, one scenario was described at 3 time points: 2020, 2035, and 2050, and the second alternative future simply summarized from the standpoint of 2050. The aim here was to place participants into alternative futures and thereby get behind the what we might call the mask of current shared social imaginaries. Our aim was less to test whether mitigation deterrence would arise within the groups, although there were interesting degrees of that, but most importantly, to explore with stakeholders how serious a risk they thought it might be and how it might itself be mitigated so as to get both accelerated emissions reductions and GGR delivery. In practice, we saw all of the mechanisms identified earlier also emerging in the deliberation. So these failed substitution, rebounds, and imagined offsetting. There was evidence that all of those were worrying our stakeholders as perhaps abstract or practical ideas, risks that might affect other people, but also emerging in the ways that some of our participants approached the discussion and the debate. And in particular, many people needed to be reassured that we were serious about seeking GGR delivery as well as accelerated emissions reductions before they were willing to think through the problem of mitigation deterrence. The conversation and debate in our workshops explored possible drivers of these mechanisms or problems at multiple levels. And these three came to the fore. A shared understanding of how the world works that makes it difficult to reject substitution and trade-offs, even across time. The remarkable political traction of exaggerated claims and promises, as seen widely in the Brexit debacle, I would say, but more generally in fake news, and the insidious impacts of vested interests working to short-term financial incentives. So as a result, plausible routes to deterrence emerged in all the scenarios we discussed. Participants did raise the sort of objections to concerns about mitigation deterrence that some of you might still have in mind. These are the main ones we heard: that GGR is needed as well as emissions reduction, so therefore no one would try to substitute them. That it is more expensive to do GGR than emissions reduction, so therefore there would be no substitution. And that decision makers would forestall serious deterrence. Someone would do something to prevent substitution. When stated boldly, as I have there, all of those are marked by something of a naive rationalism, which is at odds with the contemporary post-truth culture. Together, they reflect a liberal administrative social imaginary, which, as we saw with the initial examples of tree planting and BECCS, is already vulnerable to mitigation deterrence. But just in case you need more, to be blunt, just because we need both doesn't mean they won't substitute. Models and markets assume fungibility, and vested interests might not even care if they can use GGR promises to avoid stranding of assets such as oil fields or airline fleets. Even though GGR might be expensive, lots of GGR promises include very cheap costs, while lots of desirable emissions reduction is expensive. I've got written here even over $100 a ton of carbon dioxide. I was just calculating the cost of the affordable housing program estimated being proposed in the US, comes out at $30,000 a ton of CO2. Lots of other benefits as well, which is why you would do it. But lots of desirable emissions reduction appears very expensive. And past experience also makes it unlikely that someone would do something. Exaggerated technological promises have a remarkably long life, even when material delivery is negligible. Think, for example, of fusion power, so long, 40 years away. Perhaps for the last 40 years, it's been 40 years away. Certainly haven't seen it yet. The same applies more recently to CCS. Worse, growing climate impacts threaten to undermine capacities for rational, coordinated response, even at the same time as they might make it seem more desirable. We also sought in this analysis and the workshops to try and cast some light on whether some technologies or political settings were more vulnerable to mitigation deterrence. And there were some trends sort of indicated here on the slide, but in general, we concluded that all had vulnerabilities, although often through different mechanisms. And clearly more empirical work would be desirable to analyze these differences in detail. So coming into some conclusions, these are what our stakeholders recommended as policy interventions to reduce deterrence and enhance delivery of additional GGR. All of these suggestions came up in multiple groups, and in the end we held 9 groups. They ranged from the nitty-gritty of monitoring and verification to broad economic and cultural change through media reform and corporate accountability regulation. They combined measures to strengthen delivery with those to deflate exaggerated promises. They emphasized restrictions on substitution and fungibility by seeking to constrain use of offsetting and trading, and to formally separate GGR targets and accounting from emissions reduction. combining those outputs with some reflections from the work as a whole generates this set of, I call them policy recommendations. Alongside the principles of separation of emissions reduction and carbon removal, or GGR restated here, we see a need for broader assessment, greater and earlier public involvement, reforms in how policy uses modelling, support for more research in the humanities, arts and social sciences to help improve understanding of climate procrastination, and looking forward, efforts to embed GGR policies in a climate reparations strategy so that they genuinely support climate justice. My last slide is some reflections directed at us, or those of us in this group who see ourselves as part of the GGR research community or the broader climate research community. How should we respond to this research and findings? Well, first, I think we have to take the mitigation deterrence problem seriously. It's not just a knowledge deficit that can be overcome by shouting louder about GGR is needed as well as mitigation. We need to find the mechanisms to make sure that happens. And to do that involves recognizing that models and policy presumptions about market mechanisms are both implicated along with other factors. It behooves us, I think, to try to understand the political and emotional appeal of further excuses for delay, and where we can, to avoid feeding them. And that, I think, bears particularly on some of the modelling work, which in the past has fed those excuses. It would be good if we could undertake more detailed analysis of the potential political and psychosocial mechanisms by which those excuses for delay emerge, and the emotional work involved in resisting them. And finally, I just have to recognise that although we were able to do 4 online workshops, which gave us international participants, our participants across all our workshops were overwhelmingly from the global north. And we need to do more deliberative work with stakeholders, particularly internationally, particularly in the global south, where many GGR technologies, or particularly biological ones, may well have their biggest impacts, to try and broaden our understanding and improve responses. So thanks for listening. There's the publications and some other relevant references. And back to Phil for question session.
Yeah, thanks, Duncan. That was fantastic. I've turned on your ability to unmute yourselves and the chat function. So do raise your hand or pop a question in the chat, and we can ask Duncan to answer it. If anyone would like to go first. Okay, maybe just to kick us off then, Duncan, I'll take the liberty and ask the first question. When you were speaking, I was curious to know if you thought about conditions in which substitution might be acceptable, or is that something that you've asked in your research? Where we obviously want to limit substitution because we need to reduce emissions considerably, but under what conditions is that substitution acceptable? Is that something that's crossed your path?
Yeah, I mean, implicitly in asking the question of is this too big a problem, we're posing that one. Obviously, if substitution is at the margins, then it may not merit the effort that would be needed to suppress it. I think. And the other obvious question is, are we genuinely, or are we making things much more expensive by insisting on separation? That would be the defense for substitution, I think, generally. The motive is often as I say, in the models at least, it's this cost optimization. And my answer to that, I guess, would be that substitution on cost grounds would be acceptable if there was a genuine underlying equivalence. And I think our problem is that particularly with these substitutions across time, where the models are saying, yeah, we should do lots of carbon removal in the 2050s, 2060s, 2070s, and not as much mitigation in the 2020s. They are not equivalent. And they're not equivalent when it comes to, are we taking fossil emissions and putting them in the biological cycle? And are we making our costs equivalent? If the costs of the emissions reduction are, we just look at the costs and not, for instance, the health benefits of associated reductions in particulate pollution, then again, there's not a real underlying equivalence. So the theory, yes, it would be reasonable if there was a genuine equivalence. In practice, I think the equivalencies are very hard to establish.
Thanks. I think, Paul, you want to get a question in, and then we'll go to Chichero.
Yes, okay. I'm Paul Anderson. I'm in Illinois, early in the morning for me. And an absolutely fantastic presentation, stimulating. The question that I raise, and I appreciate a comment. We have 40% of the world's population still cooks on cook stoves, okay, wood and things like that. The poorest of the poor people. There is a solution for that, which is a gasifier stoves, which do make charcoal. This is a actual physical carbon sequestration technique that can be utilized. If the stoves are implemented and for the purposes of helping poor people, nothing with regard to the climate at all, does that change the equation at all? Should we be doing that type of work? And specifically, the airlines flying all over the world cannot get a substitute fuel is available. Should they be able to buy these, put the stoves into the households of these people, and then they actually, they're mitigating or they're replacing the something which they cannot otherwise handle. I'm involved with that. Anyone interested, I'm happy to talk about it. I'm interested in your response, please.
Okay, I'll try and give a very quick comment, because it's a huge topic there. The first thing I'd note is that there's nothing in that particular setup that is about carbon removal. So this is an abatement offset. This is a question of should we allow or we want to encourage abatement emissions reduction in the use of cooking in the global south? Great, of course we do. Should we let that, or should we try to make more of that happen by allowing people to buy or trade the carbon in an offset to allow them to fly? My answer would be no. And my answer would be no for two reasons. One, if we are going to achieve net zero, then there is no place for avoidance offsetting. Everything's got to zero or be offset by a genuine removal from the atmosphere. The other reason I would give is that it is about the sort of equivalence problem. So when we sell an offset like that, we guarantee that the emission is happening, the plane flies. What we cannot guarantee is that that cook stove is getting used. And in fact, the data on cook stove offsets suggests that they're one of the most worrying spaces, because huge amounts of them don't get used consistently. So they've been packaged up as a ton of carbon saved here, but it doesn't materialize.
I'm very sorry. The cook stoves that I'm referring to are pyrolytic gasifiers. They cook with the gases and they produce charcoal, which is carbon removal from the plants first, and it's pyrolytic to make biochar, which is long lasting. It goes into the soil, is not being burned. Please do not confuse those cook stoves with the ones which are generic and other things. So that's, I agree.
Okay.
I am interested in your issue though. Thank you very much.
Yeah, I think maybe we move on to another question. Thanks, Paul and Duncan, for the response. Chinchiro, if I'm pronouncing that, Chinchiro, if I'm pronouncing your name correctly, do you want to come in? You've got your hand up.
Yeah, thank you, Chin. Thank you, Duncan. I'd like to ask you about the supplementary. You said in the beginning we want to see this GGR as supplementary to the mitigations. But my view is because even though it's GGR is supplementary, it still need to be the substitution with mitigations, because the prospect of the mitigations, we cannot mitigate all the CO2 emissions, and that's why the people think the GGR is necessary as a substitute. So I want to know what you mean by supplementary. Is it supplementary based on the substitution, or it's not based on the substitution? And yeah, that's my question.
Okay, thanks, Shin. Yeah, as you point out, it's a little more complex than I made it out to be, but the in my understanding, and I think a sort of good common understanding of net zero, let's use this idea of net zero as a way of framing our conversation here. Countries are going to do, or entities are going to do their level best to minimize their emissions. They're going to have maybe 5 or 10% of the sort of emissions that we have now left that will need to be netted off, compensated for by removals. So in that sense, yes, there is a need for GGR to be well, it's not a substitute, it's netting off for the things that cannot be reduced. And that's a small amount. There's a second purpose for GGR, which is generally understood, which is that it seems unlikely that by the time we hit net zero, we will still only have enough CO2 in the atmosphere that we're within 1.5. So we're going to need to take greenhouse gases out of the atmosphere in some sort of process of drawdown out, so we go net negative. So that's a second purpose, distinctive purpose. That one I want to maximize. That's where I see the possibility for GGR to be part of climate justice, to be a reparation strategy, because it's actually dealing with the historic climate debt of excess emissions. There is then, to my mind, an illegitimate form of substitution, which is when countries or entities do not pursue the maximum possible swiftest path to minimal emissions, but instead use promises of future GGR or even current GGR to say, well, we're going to go more slowly. And what most worried me about the work that we did was discovering in the model worlds, in the modeling literature, largely unconsidered, that when GGR technologies were added into the models, they reduced short-term mitigation. There was a substitution that wasn't even mentally being done. It was just happening because of what was in the black box of the model. And that sort of substitution is possibly the worst and the one that we want least of. So to summarize, yeah, residual emissions, but who defines what's residual? Who defines whether it can or can't actually be reduced in 2040 or 2050? Someone might say today, well, steel, we need coal to make steel. But do we? Will we? Will we not be able to do it with hydrogen-based technology? People might say today, we'll need to burn kerosene to fly. Will we still need to burn kerosene to fly in 2050? Is that a legitimate substitution or not? So there's a next layer of worrying about who gets to define what is reasonable to substitute, to treat as a residual.
Thanks, Duncan.
Yeah, thanks, Duncan. And thanks, Shin. I should say, folks have been putting some questions in the chat, but Neil's has been doing a good job as sort of goalkeeper and has answered some of those online. If anyone would like to sort of ask a question with the webcam, they're more than welcome to. I think there's one question in here about from Joshua about reframing carbon offsetting as offsetting past known emissions rather than future uncertain emissions. And I suppose, do you have any thoughts on sort of offsetting carbon debt, or is that something that you've thought about?
It's not something we sort of really engaged with in the project. It's sort of where some of my thinking's been going more recently, and we held a panel at AEG where we were looking at trying to get lessons from net policies in biodiversity and in climate, and the marketization of offsets was always seemed to be one of the hardest nuts to crack. What about reframing offsetting? Yeah, if we could reframe offsetting at all, it would be good, because offsetting is a very fuzzy term, and in this space, I think my biggest worry is that we loosely use offset for the process Shin and I were just talking about. So there's a residual and there's a counterbalancing removal, and that is in common language an offset, but it's not necessarily a marketized process in which the CO2 is commodified in chunks of a ton costing a certain amount and traded across that border. I think that there's certainly a case for perhaps creating a product that is I mean, the NGOs did a bit of this in the early days of offsetting. They said, we'll buy carbon on the carbon markets and retire it. So we don't use it as a legitimation for flying or for doing something else. We're just retiring that credit. So yeah, you could in theory create a product like that, I guess, that we could push governments and indeed perhaps even companies that have overexploited in the past to force them to buy those retirements.
Thanks, Josh, for the question. Stefano, you've stuck your webcam on. Would you like to? Oh, so false webcam. Okay, so I suppose, if anyone's got any questions, then please do either stick your webcam on or stick your hand up, and you can ask them. I think the question from Claire's, whether it's a comment or a question, she asks, is where you define where the residual emissions are, seems to be really quite important. Maybe I'll just ask it in its entirety. Who gets to define where you set the residual emissions? There's also a justice dimension to hitting zero without GGR.
Yeah, no, that's absolutely right. There's justice dimensions all over the place here, and that's something we need to keep remembering. And it's one of the reasons I think, or I argue, the point of our project was to get the GGR to happen as well as the emissions reductions, was that would potentially be more just. But who gets to define where you set the residual emissions? Yeah, or what is a residual emission? At the moment, we're seeing lots of companies that are making net zero pledges. Many of them seem to involve not very ambitious actual cuts in their own emissions, and very big promises of particularly tree planting, but in some better cases, technological removals or investment in geological storage or whatever. But in doing so, they are implicitly, politically saying that the emissions that they can't reduce or that they're not going to reduce are somehow critical residual emissions. That's a political play going on, and it's big, wealthy companies in the global north that are saying our emissions are critical, and they're saying we're getting first dibs on the removal capacity of the planet. So to me, it's a huge justice issue on both sides there, which gets worse if we're talking about oil companies or airlines or whatever, because the continued operation tends to have environmental justice implications for frontline fence line communities at those facilities. So a triple whammy.
Yeah, thanks, Claire, for that sort of comment question. I think we've got time for one more question. I think, Olivia, you had your webcam on. Do you want to?
Yeah, thank you.
Ask the last one? And I should say, any questions that in the chat that are left over in the chat, if Duncan, if you're all right, sort of answering them offline.
Yeah, I'll happily have a go at them after the conversation's over.
Yeah, great. So Olivia, please.
Yeah, I was just thinking, in practice, how do you see these sort of targets and deterrence and mitigation efforts of different companies actually being policed, both like nationally and globally? And I know it's quite a big question, but just wondering how you see it.
That is a big one, because I see that as a problem that has evolved out of the pressures on the international system. So in the move, particularly in Paris, to nationally determine contributions and a very much a voluntary bottom-up ethic, which I'm not going to deny, it seems to have worked to some degree to stimulate countries to get more enthusiastic, but it's taken away this idea of there being some sort of anything more than peer pressure. So yeah, and Paris countries will look at each other's commitments in a round and say whether they think they're collectively good enough and have a ratcheting up. There's no equivalent as yet for business. And yeah, I mean, I'm a long-standing fan of the idea that we actually need to bite bullets and regulate. And I suppose just a little bit of hope in some of the first moves of the Biden administration on global corporate taxation, because if we can solve that problem, then countries can regulate corporations on all sorts of things without being constantly under the threat that they're just going to hop and go to some other country or take their head office to some other country. So hopefully that would allow us to regulate those corporate pledges, amongst other things.
Cool, thank you.
Thanks, Olivia, and thanks again, Duncan. I'll draw this to close now, if you don't mind. Yeah, again, thanks, Duncan, for that really wonderful talk, and really glad you could give it to us. We'll pop the recording on YouTube so you can all review it at your own leisure, and that will join the rest of the talks that we've recorded as part of this webinar series. This is also a reminder to do keep in tune with us. We'll have another sort of series or mini series of webinars sort of later in the year to present some of the projects that haven't had an opportunity to present yet. So do keep an eye out for that, please. But otherwise, thank you again for Duncan for presenting, and thanks everyone for coming along. So have a lovely day, and hope to see you again soon. Bye for now.
Okay, thanks for the opportunity.
Bye-bye.
Thanks, Nils.